Hey, this is Mrs. Rodolfi, and I'm going to go through task 1 of the Unit 5 quadratic equation project. So this will go along with the example final draft slides that we have posted. So you're going to need to choose one quadratic function for this section in the quadratic functions bank that we have posted on Google Classroom. You want to write the function in function notation and write a paragraph describing the characteristics of the function using the components below. So let me go through an example that we have on the slides to show you how to go about solving for these and writing your paragraph. So the first thing is chosen function is written in function notation. So let's say I chose this equation from the equation bank. So to write it in function notation, all we have to do is put f of x equals, and then you put your equation. And that's it. All right, direction of parabola statement. So remember, the parabola is the U-shaped. So since you can't see my Desmos screen now, I printed out a picture of the Desmos graph. So this would be the shape of my equation, negative 2x squared plus 16x minus 30. And this is a parabola that's opening down. And a way that you can easily tell just by looking at the equation is if your a value is negative, then it's going to be opening down. And then I also typed in another example of an alternate type of parabola. So like, let's say we just had x squared. Remember, there's that invisible 1 in front of it. That one is positive. So therefore, the parabola would open up. So if your a value is positive, your parabola is going to open up. And of course, you would want to use Desmos to double check this to make sure you are clear on what is happening with your parabola. All right, so mine is opening down because my a value is negative. So remember to use the fill in the blank statement that they have provided on the directions. So the parabola for this equation opens down because the a value is negative. All right. And then number 3 says on the directions page, the rubric, maximum or minimum value, a statement that says the parabola has a blank because blank. So now going back to your Desmos graph, so let me go back to my printed one. So the vertex is also the maximum or the minimum. So if my parabola is facing down or opening down, mine would have a maximum. It has a highest point here. So it has to be like a definitive point. If yours was opening up, then it would have a minimum here. So ones that open up have a minimum, ones that open down have a maximum. So to fill in the blanks, I would say the parabola has a maximum because it opens down. Vertex and axis of symmetry work in statement. So going back to the rubric, it says show work on how coordinates were found algebraically and a statement that says the vertex of the parabola is blank and the equation for the axis of symmetry is blank. So to find the vertex, we need to use the formula negative b divided by 2a. And so going back to my equation, my a value is negative 2. That is the coefficient of x squared. My b value is 16, the coefficient of x, and my c value is the constant, which is negative 30. So for the formula, and this is x equals, so x equals negative b. So remember, put your negative on the outside of the parentheses and then substitute your b value inside the parentheses, over 2 times a, which is negative 2. Remember, if it's just negative on the outside, there's that invisible negative 1. So negative 1 times 16 is negative 16. 2 times negative 2 is negative 4. Negative 16 divided by negative 4 equals 4. So this is going to be my axis of symmetry. X equals 4. And then again, use Desmos to check your answer. If I go back, remember my maximum value is my vertex. The axis of symmetry cuts the parabola directly in half at this point because it's symmetrical on each side, so it's a mirror image. And notice how it is cutting it right here at x equals 4. So that line of symmetry should be cutting it right in the middle of the vertex at that x value of the vertex. All right, then we want to also find the ordered pair for the vertex. So we know x equals 4. Now we need to find the y value. So we would go back to our original function and substitute x equals 4. So anywhere I have x, I'm substituting, oops, that should be a 4 there, 4 minus 30. All right, then solve for it. Remember to always do exponents first, so we would do 4 squared, negative 2 times 16, and then 16 times 4 is 64. All right, then negative 2 times 16 is negative 32, plus 64 minus 30, so negative 32 plus 64 is 32. 32 minus 30 is 2. So f of 4 equals 2. So to fill in the blanks, the vertex of the parabola is, so going back to what we just solved, the x value is 4, the y value is 2, so the ordered pair is 4, 2. And the equation for the axis of symmetry is x equals 4. So your axis of symmetry will always be the x value of your vertex. And then number 5 is the y-intercept work and statement. So going back to the rubric, it says show work on how to find the y-intercept and a statement that says the y-intercept for this function is blank. So to find the y-intercept, that ordered pair is always when x equals 0. So using our function, we're going to find f of 0. So I'm going to substitute 0 for x and solve. So again, first square, 0 squared is 0. 0 times negative 2 is 0. Then we have 16 times 0. So 0 plus 0 minus 30 equals negative 30. And so the y-intercept for this function is 0, negative 30. Again, use Desmos to check your answer. The one that I printed out does not actually zoom out enough to show the y-intercept, but if I did go to Desmos and zoom out, I would see that my y-intercept is at 0, -30. So again, always use Desmos to check your algebra work. All right, next one is number 6. Roots, zeros, x-intercepts, and solutions. So this one tells you on the rubric, describe what the solutions are in general for a quadratic function, and then explain how many solutions your function has and explain why. To verify the solutions, show the roots on the graph and use one additional method to solve for the solutions. All right, so describe the various types of solutions, the number of solutions your function has, and why. So I'm going to let you look back in your notes and tell me on your own paper what the various types of solutions are, but just do a fill in the blank. You can say the various types of solutions to a quadratic function are, and there's 3 different types, I'll give you that much. So blank, blank, and blank. All right, then you want to say how many your equation specifically has. So the equation that I have, I could say this quadratic has 2 solutions. And remember, the solutions are where it's intersecting the x-intercepts. So if we go back here, we can see, oh, something I meant to point out earlier was the vertex that I had just found for number, what was that, number 4. Always check again on Desmos for your vertex and all your points to make sure they show the same on the delta math. So remember that was at 4, 2, which is showing on my graph, so matches with my algebra. And then now let's see if my algebra matches. So one of the x-intercepts is at 5, 0 here, and the other one is at 3, 0. So let's see if my algebra shows that. So this quadratic has 2 solutions because it has 2 x-intercepts that are rational real numbers. And then my roots, as I just pointed out on the graph, were 5, 0 and 3, 0. So now let's solve that algebraically. So remember, there's different methods in your foldable, the 5 ways to solve quadratic equations. And so you can use factoring, the square root method, completing the square, and the quadratic formula for this. So I'm going to use factoring for my method. So if I have negative 2x squared plus 16x minus 30, I want to get it equal to 0. And then reminder to always check if there's a greatest common factor. And I know between negative 216 and negative 30, those are all evenly divisible by 2. So remember, or actually by negative 2, I can take out my negative, because when I'm factoring, it's most ideal to have a equal 1 to just have x squared. So if I know if I divide negative 2 by negative 2, I'll get positive 1. So if your a value is negative and you find a GCF, I would definitely divide by that negative to get that out of there. And then remember, when we divide by the GCF, we have to put it on the outside of the parentheses. And then negative 2x squared divided by negative 2 is x squared. 16x divided by negative 2 is negative 8x. And negative 30 divided by negative 2 is 15. All right, then we want to use that x puzzle. So remember, the top of the x is your a times c. My a value is now 1. Remember, there's that invisible 1 in front of x squared. 1 times 15 is 15. And then we want to add our factors together to get our b value, which is negative 8. So again, test out some numbers if you need to. Use that resource in your notebook. Going back to it right now, in Unit 5, the factor pair signs flow chart. So if I know my a times c is positive and my b value is negative, it's showing me that both factor pairs have to be negative. So I would use this flow chart to figure out your signs. All right, so test out some different things. So like 15, I know 1 and 15 are factors, 3 and 5, and that is it. So out of those, I know that negative 1 times negative 15 equals 15, but negative 1 plus negative 15, that's going to give me negative 16. I know negative 3 times negative 5 gives me negative 15, and then negative 3 plus negative 5 gives me negative 8. So those are my factors, negative 3 and negative 5. All right, so then to rewrite it, we keep that negative 2 on the outside, and then factored form, if one of my factors is negative 3, I put x minus 3 times, and then my other factor was negative 5, so x minus 5. Then we need to put each of these factors in parentheses equal to 0. X minus 3 equals 0. Add 3 to both sides, solve it. X equals 3. Look, that matches one of my x-intercepts up here. X minus 5 equals 0. We would add 5 to both sides. X equals 5. So that also matches my other x-intercept at 5, 0. All right, then number 7 is the graph of the parabola must be drawn on Desmos, label the vertex, the axis of symmetry, the solutions, and the y-intercept. So you're pretty much taking everything that we just showed work finding, and you're going to label the ordered pairs on your Desmos graph. And then you need to upload the PNG onto Google Classroom for your rough draft by the due date to make sure I can check that you have everything labeled to get your full points. Otherwise, you'll have a chance to make corrections if needed. But just a reminder, when you're graphing on Desmos, and I'll post another video that shows you how to graph all these things, but also make sure you save it. You need to log in using your Google account. So you log into Desmos, and then you can save all your graphs for each task so that you can easily access them for the final draft and easily have them ready to go just to make corrections so you don't have to start all over. So I will upload another video for number 7. And then the bonus is to find 3 additional points. So show work to find 3 additional points on the parabola. 1 point must be found by explaining the symmetry of the parabola. All right, so let's say I want to do x equals 1. So if I do f of 1 equals negative 2 times 1 squared plus 16 times 1 minus 30. So first we would do 1 squared, which is 1. 16 times 1 is 16. And then negative 2 times 1 is negative 2. And then negative 2 plus 16 is 14. 14 minus 30 is negative 16. So remember, your x value is inside the parentheses, that's 1. Your y value is what it's equal to. So one of my ordered pairs is at 1, negative 16. Then let's say I want to find when x equals 2. So f of 2 so again, first do exponents, negative 2 squared is positive 4. Just a reminder, when you're using your calculator for exponents and it's a negative number, you have to put it in parentheses. So -2 times -2 is +4. 16 times 2 is 32. -2 times 4 is -8. Plus 32 minus 30. And then -8 plus 32 is 24, and then minus 30 is -6. So my next ordered pair, x equals 2, y equals -6, so 2, -6. And then if I go back to, so now remember, one of your points you have to use the axis of symmetry. So if I go back to my Desmos graph, so let's see if it's, oh good, it shows here. So 2, -6 is right here. So if my axis of symmetry is at x equals 4 here, I know that I have to add +2 to get to the axis of symmetry, and then if I double that, I have to add 2 again. So I have to move a total of 4 points to get to the other side that's symmetrical to this point. So this point is at 2, -6. So I'm adding a total of 4 points for my x value. So 2 plus 4 would be 6, and then my y value stays the same, -6. So explain something like that. Explain how much are you moving on the x or the y axis to get to the symmetrical point on the other side of the axis of symmetry. So for this one, I would say the axis of symmetry, I'm just going to put AOS for short. So the axis of symmetry is x equals 4. So if I do 2 plus 4, since currently 2 is 2 units away from x equals 4, and then I would have to add another 2 units after that to make it symmetrical. So I would add 4 to my x value of 2 equals 6. And so my symmetrical point would be at 6, -6. All right, that is it for task 1. Thank you for watching.